Hi, in this video, we want to take a look at using ggplot with the USA boundaries and USA boundaries data packages. Okay, so a viewer let me know yesterday that the USA boundaries package, it has been archived on CRAN. I looked and there was some problem with CRAN standards of packages with USA boundaries, and it's been archived. You can still get to archived versions. That is possible, but what I feel like is a better choice for the time being right now is to go to docs.ourOpenSci.org USA boundaries. And there you can use the GitHub package method to download these two packages. So in general, overall, overwhelmingly, I strongly recommend sticking to packages on CRAN if you can. CRAN makes sure that everything on the repository at least meets a certain standard of a minimum standard that needs to be reached. If you start going off of CRAN, you can get kind of like out into the wild, wild west. Now, this is actually one of my biggest complaints about Python is the lack of standardization and lack of minimum standards for the modules in Python. Pandas is great, scikit-learn is great, SciPy is great, NumPy is great. Like the core ones are really, really good in Python, but the moment you step out of those core modules, all of a sudden quality can just drop off like that. And so to me, this is a reason for R to be embraced more by the data science community, because if I get a package from CRAN, and there's a lot of them, the authors had to go through a process of documentation and package and function quality that isn't required by packages that are on GitHub and or the Python modules. And so most of the time, try to stick with the CRAN packages. Here, I'm going to break that rule that I'm going to use the some packages on ourOpenSci.org. Okay, so here I'm just going to start like exploring and working through a bunch of examples. We're going to use ggplot, and I am teaching at the University of Central Florida, and so I'm going to be emphasizing the state of Florida on almost every visualization. All right, so the first thing I want to talk about in USA boundaries, and I'll be using the double colon notation to make sure you can see where exactly I'm getting the package each time, or the item each time, state codes. And so nicely, it gives us, the state codes of everything, of every state and the districts that I know about. So, it's just pretty standard, every American knows these. Now, something that is interesting is that in this data set, they've got other regions, they've got territories such as American Samoa, Federated States of Micronesia, Guam, and Northern Mariana Islands, and a whole bunch of other ones that we usually don't talk about so much as Americans. Like, I'm not 100% sure where all of these are on the map, but it's just interesting to know they're there, and I can do a Google search and find them. All right, so now another thing that's interesting is that if I need to get a projection for a particular region of a state, this is available in this package. So if I take the state projections data set in the USA boundaries package, I can get a projection more nuanced to the area that I'm interested in. And so here we can see that if I'm interested in East Florida, West Florida, or North Florida, if I want that to be the center of my map, I can easily grab the projection very nicely off of this. It's easy to find, easy to get. And now here we can also, there's the contemporary states that we can plot. And here we can see the okay, low res, that's low resolution, and there's high res. These two packages go high res, low res to indicate the level of nuance on the boundaries. But here we can see, the major aspects of the United States plotted on a map. Now, another thing that we would want to have, so previously we talked about nuanced areas for, not nuanced, but regions of a state for projection. We could also want a projection that's a good projection for the state as a whole. And we can get that from this package. So here, if I take the state projection data set, I pull it into my workspace. Previously, I didn't have to. On this step, I have to. If I want the state plane function and I specify my state, it will give me a projection. It will give me two types, EPSG, which is strictly a number, or if I go projection 4, it will give me a more specific laid out information about what's going on. And so depending on what I'm doing, one may be easier for my project than the other. All right, so now we can look at city locations and populations, both historical and contemporary. Something that's very nice about this package is that it has a lot of historical boundaries. So if I wanted to do a project that was historical and I wanted to put things on the map at the time, I can easily do that using this package. And so here, for example, let's say that I'm interested in US cities from 1850 on New Year's Day, and I'm interested in which ones were in Florida. Well, when I take the US cities data set, I'm going to get a bunch of spatial points, and it's going to list out a data frame, or a spatial data frame with the information. Now, you'll notice with this one, there's only one entry. The reason for that is because this is the earliest entry in the entire data set. And so or at least on New Year's Day, in terms of the year, this is as early as I could get just to show the historical aspect of it. Now, if I want to go to the most recent census, so I go to the year of the most recent census, so I'm going January 1st, 2010, and here I can see that there's a lot more cities that are included, and once again, it's a spatial point to be able to plot it on the map if I wanted to. Next one we can talk about are congressional district boundaries. So contemporary, that means that is the maybe not the most up to date, but the modern ones, or the most modern ones at the time that things were built in this package. And so we have two options. We have high resolution and low resolution. Here's a high resolution. So you can see, all these little islands by the keys. And we have county boundaries, historical and contemporary. And so here I took map date of New Year's Day on 1820, and here we can see the county boundaries. This looks very different from Florida today. And I can take the county boundaries for New Year's Day on the year 2000, and that looks a lot like what we have today. Now, state boundaries, we can do the same thing. Florida isn't very interesting. This is 1820 was as far back as I could get it in terms of New Year's Day, and it looks pretty similar to what we've got today. And if we go for year 2000, we see it looks pretty much the same as it did back then. There might be is there a little bit of difference here? I take a look. No, it looks about the same to me. There may have been some small changes here and there. Rivers may have moved, a little bit, but I think it's practically speaking the same. Now, the next one is the spatial dots for zip codes. And so if I take the US zip codes function, notice that this is a function, not an actual data set, but I treat it as a data set. I drop it in, and we can see all the different zip codes around the United States. And so here, we can see Hawaii, we can see Alaska, we can see, Puerto Rico, continental United States. And then these are going to be probably Guam and American Samoa. I could look at the output of the function a little bit deeper if I want to get precise. I'm just going to leave it as is. And if I need it, I'll go dig into it. Now, let's say that I'm interested in looking at where are the zip codes for the state of Florida. Well, if you look at that data set, it doesn't indicate which state they're in. And so what I'm going to have to do, I'm going to have to get a little bit tricky with it. I'm going to use the SF's function for intersection geographically. So I'm going to take the geographic intersection between the state of Florida and the zip code data, and then I'm going to plot it. And you can see very nicely, I can see where all the zip codes are in the state of Florida. And you'll notice most of the zip codes are more concentrated where there's more people. Big shock there. I'm surprised by the absence in Southwest Florida. All right, so now let's go ahead and start taking a look at the USA Boundaries data set. All right, so this is a package that has 100% packages. There's no functions, or sorry, it's 100% data sets. It has no functions, nothing else going on. It's just a bunch of things for us when we're working with maps. So it's real nice. It's got a bunch of nice historical things. So one thing it's got census cities. And so it has, I have historical data for censuses at different cities throughout the state of Florida. And if I plot all the ones in Florida, they overlap so much, it's not really possible to get any meaningful information out of them. The vast majority in the data set are incorporated cities. Okay, so what I can do, if I want to make this a little bit easier to look at and to interpret, I'm going to go with all the ones that are non-incorporated cities, all the other types, and here we can see the population growth for each one of them during the different US censuses. And so here we can actually see the data set. So it's just the first few rows. I've got sorted so that the highest population is at the top, and then it's sorted by year. And so we can see largest population is, and so it's first sorted by population. And so Jacksonville can appear again lower down in the data set, but the most populated city in the entire data set is Jacksonville, followed by Miami. And now I would say that there's more people in Miami-Dade County than there are in Duval. I think when people say Miami, they're usually talking about the Miami area. And so most people would say Miami has more people. That's because of the Miami area. Well, I think Jacksonville, like the Jacksonville area is proportionally more pure, true Jacksonville. Now, next thing we can look at is the congressional district boundaries. And so these are contemporary ones. And so we can see the congressional areas for each region. And we have high res and low res. Notice that for the low res, the keys gets really, really messed up. So I definitely wouldn't want to use this unless I really, really had to. I would definitely want to use high res on any project. Now we can go with our county boundaries. Now there is a problem with this data set. The state name column name appears twice in this data set. And so this can cause a problem when you're trying to use certain function. It caused problems when I was preparing for this video. And so what I did was I pulled the data into my workspace, and then I used the janitors package, make clean names, to clean up the names so that we had unique names for all the columns. Then once I did that, everything worked out fine. Everything plots the right way. And so here we can see the high resolution county maps. I can go down, do the same thing, fixing up county names, or the column names. And I see once again, I've got this weird aspect to the keys. Now we can also go through and get historical county boundaries from this package, which is a really cool aspect of this. And so here we're going to look at the year 1845. And so with these historical maps, the maps, were in effect correct for a certain time span. And so when I'm looking at older maps, they're, like each county has different years for each individual map that it has. And so there's, if you look at the data set, you need to like specify what year you want for start date and what do you want for end date. And so here I picked this one because there's a Mosquito County in this map. Where is it? I don't know. I could dig into it later, but I thought that was interesting, so I went ahead and grabbed that. Here is the low resolution version. Yeah, this looks pretty ugly. I definitely wouldn't want to use this. Now, state boundaries, we have high resolution, low resolution. The standard state boundaries, not too interesting. We can also do historical state boundaries once again. But it's for Florida, it's not that interesting. Maybe if we went out to like Oregon, it might be a little bit more interesting there. Low resolution. And now once again, we have zip codes. We have a second data set for zip codes, and I'm just pretty much just playing the same game. Here are the dots that indicate the centroids, not the location of the post office. All right. Well, that's all I've got for you. Life is short. Do math.